Hello everyone, April 12th. All right, let's not delay. Well, we have to delay. Take a look here. I don't know anything new. All right, let's go for it. Beautiful arrangement. 2. I might have done 1. Given 2 integers, you need to construct a list which contains n different positive integers ranging from 1 to n and obeys the following requirement. Suppose this is the list, and the list a1 minus a2, so it's adjacent. The difference between adjacent has exactly k distinct integers. If there are multiple answers, print any of them. So it could be n different positive integers ranging from 1 to n, so it could be any 1 to n, right? So if 3 then has 3 different positive integers ranging from 1 to 3, and 1 has exactly 1 distinct, okay? 2, we have 2, 1, okay? Alright, so 1 to n, that one is already determined. So what we have is a permutation of 1 to n, right? So we have a permutation of 1 to n, and what we need to satisfy is this has exactly k distinct integers. All right, so we know if we do 1, 2, 3 all the way to n, then we have 1 distinct integer. If we need 2 distinct integers, all we need to do is do a swap, I guess, because it's swapping here. So what do we swap? We swap the last 2. Okay, so here n minus 1 and n, right? N minus 2. 1, 2, 3. And if we swap the last 2, we have n and n minus 1. And then we have, this is n, this is n minus 2, then we have a 2. So we have 2 distinct, right? What if we want 3 distinct? If we want 3 distinct, then we do the last 3, right? 1, 2, 3. So we're going to do n minus 2, n minus 1, n, and n minus 3. If we swap the last 3, n, well, not swap, just like reverse the order. N minus 1, n minus 2. We have 3 and 1 and 1. No, that's not good. So it has to be n minus 2, and n minus 1. This way we have 3, 2, and 1. Okay, what is the rule here? So basically we're going to swap the last 2 and then swap. Okay, so here's what I'm thinking, right? So we have 1, 2, 3, da 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 da, and we have n. Let's try 4, right? n minus 4. That's just like n minus 4, n minus 3, n minus 2, n minus 1, n, right? So that's that. So what we want to do is to get 4 of them that's different, right? So what we do is we swap the last 2, right? We swap the last 2, and then we swap these 2, and then we swap these 2, and we swap, I think it's not correct, these 2. No, we do not swap these 2. We leave it here. So we have 4, we have 3, we want 2. So actually we have to swap these 2 as well. So we have, this is 4, 3, 2, right? And the last one is 1. So what is the rule here? And we don't have to swap from the bottom. We can swap from the front as well. We don't have to swap from the bottom, right? So in this case, we know that we want to, so we want differences, so we want to have 4 different, right? So we go 1, 2, 3, and 4. So 5 minus 1, so we have to put 1 here. right? We have to put 1 here. And then we need a 4. 4 we have. Now we need a 3. So 4 has to be here. Now we need a 2. 2 is here. And we need a, and the rest, 3 can be put here. So what is the what is the rule? So we put the smallest right after the biggest, right, to create the k. So 5 minus 1 is 4. And then we put the next smallest, so we need 3. So we say 1 plus 3 is 4. Then we need a 2. Then 4 minus 2 is 2. Okay, so what if we want to do 3, 4, 5, 6? What if we want to do 5? Right, so when we do 5, we get to 6, right? So we know this one has to be 1 because that's 5, and then this one has to be 5 because that's 4. Now we need 3, so 5 minus 3, we got 2. Hold on. How do we get 3? Well, we get 3. 3 should be getting from 4. We cannot get. It's not. Oh, hold on. I thought I got it, but I don't think I actually get it. So 1, 2, 3, 4, 5, 6, right? We want to get difference is 5, 4, 3, 2, 1. Alright, we want to get 5, so 1 has to swap here, so that we get 1. So, right, 5, we got 5, and then 5 is here. Now we want a difference is 4. So the difference is 4 can only be get by putting 5 here. Alright. Now we need a difference is 3. We don't have differences 3 because now we do have differences 3. So we put 2 here, and difference is 3. And then difference is 2. We have differences 2. Put 4 here. How can we do a system? Yeah, like this, right? So you can do 3, 4, 2, 5, 1, 6, right? So this is 5, this is 4, 3, 2, 1, right? So I think anything can be arranged this way, but the question now is, what is the rule here? Well, the rule is we find the biggest one. I put 1, like we have the biggest one. So actually it's the k plus 1, right? We find k plus 1, and then this location has to be 1. So we got this k, and then this location has to be k to get k minus 1 is 4. And then we need 3, so this minus 3, we put whatever number is minus 3. Then what? Then what? Then we need a 2. All right, let's take a look at 7. So how does 7 do? So we know if we want to have 1 to 6, right? 6 unique value. Then we have 7, 1, and then that's giving me 6. Now we need 5. So 5 can be getting from 6, right? 6. So now we need 4 to get 4. Now to get 4, we can do 6 minus 4. That gives 2. Now we need 3. Now 2 cannot minus 3, but 2 can plus 3. That gives us 5. Now we need 2. 5 minus 2 is 3. Now we 1. 3. Well, 3 cannot minus 1. 3 can plus 1. That becomes 4. So I think I can just do it that way, right? We get a value, and then minus. If it cannot minus, we plus. If it cannot plus, we minus. Not sure, but we're gonna give it a shot. I have a general idea. Gonna try to see if it works. The idea is can we like build it? We build it from the back to the front. Oh, the order doesn't matter. The order does not matter. So if I do 7, 1, 6, 2, 5, 3, 4, and then something else, that doesn't matter. So I think if the order doesn't matter, then that would be fine. All right. So I don't think I'm gonna write in a test case because it said it can return anything. So I'm not gonna do that. So rest gonna be list range 1 to n plus 1. Right? And then we're gonna say we want k, right? K values. So k6 or k will be the largest. So we're gonna call say for largest. I can construct from the front. Okay, for 1, right? 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7, right? Now we're going 7. 7 minus 4 is 3. So it's 1, 2, 3, 4, 5. That is not working. So we have to start. All right, so what we're gonna do is we get the 0 position is going to be 0 position is going to be 0 position is going to be k plus 1. All right, k to 1, 0 position is going to be 2. And then, hold on. If 0 position is, are you saying 0 position is 2? I don't really think it's working that way. So we have 1, 2, 3, right? So if k equals 1, so the maximum is 2. So look at 2. And then we have to go to the left, I think. And then we do 1. Yeah, I think we have to go to the left. It's just, I don't think it's possible to do the other way. So what do? We're going to say I. Well, I is going to be, what is I? I is index, all right? So we're gonna say for I in range k, right? 0, 1, 2, 3, 4, 5, 6, yeah, k, and minus 1, right? So we're from k, and then we're gonna say, well, it's actually gonna be 0. We're gonna say res I minus 1, right? Equals what? Equals res I minus k if res I is larger than k, else res I plus k. All right, so do this, and k minus equal 1, so k decrement, and then we do it again, right? Next one will be here, 1, and then minus 1 will be res I larger than k, 5, no, so plus, and then we 4, and 3, 2, 1. When we're done here, we can return res. All right, let's take a look. I think the first test case is 1, 2, 3. Okay, input is 3 and 2. Your answer, expected answer, 2, it's fine. Can I do custom? So let's do 1. This one shall not change. Yeah, I think we have, say, 10, and we want to do 6. See if the result is what we expect. So expect answer 1726354. Our answer. I just check if it satisfies. That's not how. Okay, 7 1 6 2 5 3 oh 4. That is not correct. Hold on. How do we resolve that? Well. I think. 5 4 3 2 1. I think I can just do that. Just decrease, increase, decrease, increase, decrease, increase. Let's do that way. That'll be easier. So direction. So yeah, D gonna become 1. The first one is decreasing, so we're gonna be -1, and then this is going to be plus D times K. All right, just plus D times K. K and then D. That's 1. All right. So K decrement, D decrement as well. I think this one will correct. I shall see 4. Yep. 7 1 6 2 5 4 5 3 4. And this one shall be correct. Try it. Yep, that's correct. So it's following this like down, up, down, up, down, up. So going that way. It's possible that we make it a bit. Well, I think we can. Right? We can just say while k, right? And then no. Let's say for I in range. For I in range. No. Let's just do 0. Right? So while k, and then res I plus 1 equals res I plus d times k, and then that's the same. K minus equal 1, d times, yeah, that's the same. It's the exact same thing. So we don't need this. We don't need this. Yeah, I guess that's it. And we can talk about the solution. So the intuition is that we can always create k unique differences, diffs, k unique diffs in the first k plus 1 numbers. We construct the first k plus 1 numbers like this. One plus k, and then 1 plus k minus k, so 2, and then k, right? K minus 2, so k minus 1. So, okay, so this is k, this is k minus 1, k minus 2, k minus 3, and k minus 4, right, until k minus, k minus 5, and then k minus 6, right? So it's 1, 2, 3, 4, 5, 6, 7. So when do we stop? So we 1, 7, 2, 6, 3, 5, 4. Well, yep, that's it. That's it. And yeah, we stop when we have first k plus 1. Yeah, like this. Yep, that's it. I'm gonna change it. I think this one is better. So we just say, right, so this is basically k plus 1. And then, so it's not d, it's going to be, let's call it d. D is going to be 1, all right? And then we can just go here and a skip, right? So we're going to say for I in range to what? So going to be k plus 1, right? K plus 1. That is the total. So we'll have the first k, yeah, it's the first k values. Right, first k values. If it's 6, well, if you want 6, actually it needs 7. All right, so it has to be, it shouldn't be k plus 2. To k, if k is 5, 6. Right, k is 6 here. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 values. So if we do this, that's k plus 1. Yes. So we're going to do this. And we're going to do 2. All right, so we start from 1, and then we do 2 at a time. And then we say res I plus equal d, and d minus equal 1. Now we'll return this. See if this one works. I think it does. And I think it's better than my original solution because this one will align with the answer. Res. No. Nope. Uh-oh. That's k plus d. Yeah. Yep, that's, I think. Oh, that's not. I got something wrong here. 1, 7. And it should be 2. 1. Oh, shoot. That is actually not correct. So it's even and odd. Oh, I have to do even and odd. Ah, man. Even and odd. So, okay. Okay, that's fine. That's fine. Let's start from 0. Right, we start from 0 and 0 towards this. Yeah, and every time when we can hit it, we're gonna say so we're gonna have 2 values, right? So we're gonna have 2 sets of values. One is This is called P and Q, right? So P is gonna start from all 1, and this one is going to be P, and then rest I plus 1 is going to be K plus Q, and then P gonna be increment, Q gonna be decrement. Alright, and now return this, and we can put this like this. Yeah, the reason I do this instead of my original solution is just because I think this one is easier to explain. I think this one is easier to explain. And it actually fits the correct answer. That is not correct. I think it did too much. It did too much. So we have to also consider Q. Q has to be, okay, let's do this way. Yeah, Q minus 1, so the maximum Q can get, Q needs to be smaller than K. Yeah, Q needs to be smaller than K. So let's do this. That'll be easier. So we're gonna say while Q is smaller than K, we'll do this, blah, 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 I plus equal to 2. And then it'll be easier to determine when we end. Index out of range. No, it's not Q smaller than K. It's Q. What is it's the difference? No. Wow. What shall we say when is it end? Well, it ends when K plus Q is equal to P. All right, that's when we end. So when I say while K plus Q is not equal to P, right? Because P is the first one, K plus Q is the second one, right? And then we just keep going until a time when they're not the same. If they are the same, then we don't do it. That, I think, shall be correct. That is still not correct. Wow. It's easier to do my way, right? It's easier to do. I mean, this one you just have to consider how many times you have to do. We know. Hold on. We know. So basically, you have to consider it's even or odd, right? If it's even, no, we don't like this. This is no, we like our way. Let's do it our way. What is our way? How do we restore? Last submitted code. Yep, this is our way. So, I mean, let's do our way first, but we need to figure out how this one works. So this is how we do, right? We do K plus 1, right? And the front one will be 1, right? And then K minus 1. Yeah, K minus 1. And then 2. I think that's, yeah. And then, oh, I mean, it is obvious how this one is going. Yeah, so it's so it's 1, 2, 3, right? And then we have 7, 6, 5, 4. So 7, 6, 5 1, 2, 3, 4, right? I think that is the thing. So basically what we're saying is we know the total number. That's 7, right? That's 7. So we just populate one of them as much as we can, and then we populate the other one as much as we can. Hold on. I think it still will be better to do the other way. So we're going to say P is going to be 1, and then for I in range 0 to the end will be K plus 1, right? K plus 1. And then we're going to say res I equals P, and then P plus equal 1. And then we're going to run another loop. And this time it's going to be from 1 to this. And then res I going to equal to K minus P. All right, I'm going to say P going to equal to 0. And return res. Can we get these two together? Just yeah, I think we can. We can. Like, why we cannot get them together, right? So basically that's that, and just res I plus 1 equals K minus P plus 1, because actually it's going to be, I'm going to start with P is 0, so K is 6 minus 0 is 7, and then this has to be P plus 1, and then every time P just add, keep P kept adding, and we need to determine at this position, right? So I will always work because it's not gonna, but if I plus 1, right, is smaller than, the position has to be smaller than K, right? Smaller or equal to K, because we can get to K. Yeah, have to be smaller or equal to K. Then we do this, and then we do this. Yeah, I think this one shall be correct. Right? It's just easier to explain. Right? You just interweaving. Yeah, I think this one's correct. 5 shall work. Even number and odd number. Get a feeling. Yep. Yeah, I like this one better. Yeah, I like this one better. So it's just like this. K minus 1, then K minus 2, 5. So basically, we go 1, 2, 3 on even on all the even indices until K, until index K. We go K plus 1, K minus 1, K minus 2, on all the odd indices until index K. That's it. Runtime will be okay. Right? Okay. See, it's going to be 44 milliseconds, and we run it at 86% ranking. Yeah, I think this probably is the correct solution. This feels like a medium question to me, because I think it requires some ingenuity. Usually, ingenuity signifies that it's a medium question. All right, let's take a look, see if it's a medium question. Yep, it's a medium question. Oh, people don't like it. Why? Yeah, so it's fine. For each permutation, oh yeah, this is brute force. No. Construction. The remaining, yeah, I think we got, yeah, that's the one. Choose one from top, choose one from bottom. Choose one from top, choose one from bottom. Oh, good explanation. Actual value is different, yeah. All right, I think there's nothing more to talk about. 4 lines. Well, we can reduce it to, I don't know. I mean, this can be reduced to 1 line. And then these can be reduced to 1 line. These can be, so 1 line, 2 line, 3 line, 4, 5 lines. It has to be 5 line. Oh, Ruby, look at this. We can create the largest possible difference by making the smallest of the neighbors. Whole subarray from 2 to 10, then no other neighbors. To create the next, we bring 2 next to 10 by reversing the subarray, and so on. Ah, okay. Yeah, it's just it's fine. All right, that's it. That's it for today. It's relatively straightforward. I mean, it's a straightforward solution, and well, I have nothing else to say. So that's it. That's it. Well, we will keep working on this on tomorrow, right? So I see you guys tomorrow. Adios.